Hi, this is Alix Paultre, and I'm here at the APEC show in San Antonio, Texas, and I'm with Chris Dries. He's with United Silicon Carbide. Well, friend of the show, I should say. We've talked before, Chris. I'm glad we had the time to talk today.
Yeah, thanks a lot, Alex. Thanks for stopping by.
Well, I really like what you're doing, and the thing about wide-bandgap is it's literally arrived, and now it's a case of seeing where it's going and the products and the design in. But I wanted to talk to you especially because you've got a specific play in the wide-bandgap with your cascodes and your epitaxial silicon carbide, and I wanted to especially bring out what you're doing because it's a little bit off the beaten path of the wafer-based silicon carbide guys.
Well, this week, Alex, we released our 650 volt Generation 3 FETs, compatible with superjunction gate drives, compatible with silicon IGBTs. So our customers are able to just take out a silicon component and drop in our parts in lieu of them. And instantly get higher efficiency over the entire load range.
Well, and I think that's an important thing to bring out is a lot of these solutions have a big design-in hill, as it were. There's a ramp either for learning or design-in or dial-in, and your solutions actually being drop-in help a lot of engineers make it to that next level quick.
Exactly. So we have customers all over the world, in every continent that this has been borne out. I was recently at a customer in Taipei where they had two superjunction FETs running in parallel. They took out those two FETs, put in one of our 80 millium, the new Generation 3 650 volt FETs, and got higher efficiency. And that's even before they've taken advantage of the higher switching frequency that we can get with silicon carbide.
Well, and that's one of the other interesting aspects because you could drop this in and get an improvement out of the gate, but if you dial it in, you get even more.
Precisely. So particularly as people are beginning to move to new topologies, these 650 volt FETs are being adopted dramatically in totem pole power factor correction. So historically, a lot of people have done PFC with silicon carbide as the boost diode, but here we're beginning to replace those silicon carbide diodes with two silicon carbide 650 volt FETs.
Well, that would make a big difference.
Yeah, it is. And that's just the traditional power supply market. What's really driving our business right now are electric vehicles.
I can imagine.
Yeah, in particular, onboard chargers. We saw that business basically triple for us last year. We expect another triple in that market again this year. So much of it is being driven by China and by Europe. Your home in Germany has just announced that diesel cars will be banned in a lot of major cities. So that's yet another tailwind for our industry.
Well, and also one of the things I'd like you to bring up, Chris, is, as I mentioned earlier, you are a different play in some sense, and but there are some people who are bad-mouthing cascodes out there. They're saying that it's not enough or it's intermediary, and I'm like, well, hey, if you can get the performance advantages, isn't that the important thing?
Yeah, that's exactly right, Alex. So we view cascode FETs as giving us two independent degrees of design freedom. Right, so we have the highest performance RDSA FET in the JFETs that we make, and then we couple that with a custom designed silicon MOSFET. And what we do is we give the customers the benefit of a standard gate drive, an amazing body diode that only goes up 10% in its QRR over temperature compared to say 3x for a silicon carbide MOSFET. And we're avalanche rated, we're short circuit rated, and we're ESD protected. So we give all of these benefits to our customers because we have these independent degrees of freedom in the design of our FETs.
Very nice. Now, what's on the horizon? Do you have anything you can talk to us about?
Yeah, we have a new generation. We'll announce it a little bit later, but a new generation of 1200 volt FETs that sort of leverage the designs that we have here at 650 that we announced this week. But what we see in the future is people beginning to integrate our FET technology into higher level power supply assemblies. So not just discrete TO247s, but beginning to integrate gate drivers and control ICs alongside our FETs as the power device.
Well, and it does lend itself well to highly integrated power devices, so I would imagine that would be the next step for a while.
Yeah, it's very, very exciting. Just continuing to provide that much more value to our customer base.
Very cool, Chris. Do you have any words for our audience before I let you go today?
Just go check out our new FETs on our webpage at www.unitedsic.com, and feel free to call our sales team at any time.
Thanks a lot, Chris, for taking the time to be with us today.
All right, thanks, Alex.